Hi folks, it's Mrs. Frame. I'm just going to go over a couple of the answers and then I'll send the answers out to the whole thing, or a couple of the problems, and I'll send out the answers to the review sheet. Please study. I'm not going to be able to write down the links of the times, but I will write down in the video details what questions I did go over. Alright, so the first one I'm going to go over is number 1. Okay, so we're supposed to find the inverse of x. That's what you've been asked to do. So what we do, if you recall, is we change the f of x to y. And then the next thing we do is we switch the x and the y. And then we solve for y. So we're going to just take care of things here. Divide the 3. And we get y equals x plus 2 over 3. Last step is to change this back to function notation, and we call it the inverse of x is equal to x plus 2 over 3, and there you go. That's number 1. Alright, the next one I'm going to go over is number 3. Okay, so with number 3, you've got an absolute value equation. So remember that I can have positives or negatives inside absolute values, which means I'm probably going to get 2 answers. But before I can solve it, I'm going to rearrange it so that the absolute value is on the left-hand side. And then I'm going to follow the rules. You remember that when you solve absolute value equations, that the absolute value has to be alone first. So we're going to move everything else to the other side using the proper order. Equals -4. Now you might be a little worried, but Mrs. Frame, absolute values can't equal a negative. Well, you're right about that, but I still have to move this -2. So we get absolute value of 3x minus 9 equals +2. Since it equals a +2, we can go ahead and solve it, and we're going to solve it twice. The first time we're going to drop the absolute value sign, and we're just going to equal a +2. But remember that what's in here could also be a -2. So we're going to figure out what would make 3x minus 9 equal -2. And we're going to solve it twice. Once positive, once negative. Okay, divide by the 3. Alright? Same thing over here. Divide by the 3. X equals 7/3. So you get 11/3 and 7/3, and that's all you need to do. Remember, isolate the absolute value first. Make sure that this right side is equal to a positive or 0, and then if it's equal to a positive, solve it 2 times. So once for positive, once for negative. Next. Okay, so I'm going to go ahead and look at number 4 since we didn't do very well on our last test with these types of numbers. First, I'd like to rearrange it so that it's in the proper order. So we're going to rearrange that top to a -4 plus 2i over 5 plus 3i. Now remember that denominators don't like imaginaries, and to get rid of an imaginary complex number, you've got to use its complex conjugate. So you've got to use the opposite sign. But whatever you multiply to the bottom of a fraction, you have to multiply the top. Okay? So we're going to multiply our tops first, and that's going to give us -20, positive 12i, positive 10i, and negative 6i squared. Remembering that I squared turns this to a different sign, and we're going to regroup that, and we're going to put that with that number. We'll do that in a minute. Let's do the bottom. Now remember, with complex conjugates, you just have to do first and last. You get to skip the outside and the inside because -15i, positive 15i, they cancel each other out. So you get 25 minus 9i squared. I squared makes that -9 positive. Now we're going to simplify and write it in the right form. So -20 plus 6, -14. 12i plus 10i is 22i, and on the bottom we get 34. However, you have to write your answer in a plus bi form, which means you have to separate. -14 over 34 plus 22 over 34. Drop the I out. Also, you have to make sure that you can't reduce. And this is even. 2 goes into both of those. So positive divided by negative, we're going to get negative 7/17 plus 11/17 I. And that's the simplified version of number 4. Okay, so I want to look at number 6. So we're supposed to multiply these complex numbers. First, you've got to deal with this complex conjugate. And remember that, again, you get to skip the outside and the inside. So that ends up being 4 minus 25i squared. I squared makes that negative a positive. So this is going to equal 29 when we're all done. So I'll rewrite it. 3i over 11 times 29 over 12. Would like to cross simplify if I can, and 3 and it goes into 12. That's 1 time and that's 3 times, and 11 and 29 does not. So on top we've got 29i all over 33. We need to separate. The I needs to drop out. It always comes last. We cannot reduce. There's your answer. Okay, I'm looking at number 8. Number 8 says find the f of g of x. Guys, that's the FOG. Okay, composition of functions. Remember that. What you do is first you write down the first function, x squared minus 1, and then you take the x out and you replace it with the next function, which is this one. 5x minus 3. Then you just follow the order of operations and you finish up the problem. So you're going to multiply those two things there. And you're going to combine like terms and solve. I'll go ahead and let you do that. So once you solve it all out and you distribute and then you combine your like terms, you end up with the final f of g of x, which was equal to that trinomial there. Okay, and then you also had to do number 9 and 10, which were just basic algebra ones. So the first one was to multiply 2 times your f of x minus your g of x. And so remember that you use parentheses when you substitute. So we're going to do 2 times x squared minus 1 minus 5x minus 3. And you got to be careful because you're instituting minus a quantity, so remember that's important. Distributing here, 2x squared minus 2. Distributing here, minus 5x. Positive 3, negative times negative. Regrouping, 2x squared minus 5x. Negative 2 plus 3 is 1. And so there's number 9. The last one is a silly easy problem. Basically all you're doing is you're taking your g of x and dividing it by 2 if possible. So you just take 5x minus 3 and you put a 2 under it and see if you can reduce it. In this case it didn't work, but it's quite possible that tomorrow you might have something like 4x plus 8 over 2, and that you would have to reduce. So just remember that they go under both. That would be 2x plus 4. Just a hint. Okay? Okay, so I moved all the way to number 15. I think you should have enough help with those others with your notes that you can manage through those problems. But let's go ahead and take a look at number 15. You're supposed to simplify this problem, but you've got all these quadratics that need to be factored. So here you're going to just factor everything. X and x, we're looking at positive 14, negative 9. That's going to be negative 7 and negative 2. So we'll rewrite that as x minus 7, x minus 2. Working on this bottoms, difference of perfect squares, x and x, negative 2 and 2. So that's going to be x minus 2, x plus 2, times, working this one over here. I think we're going to have to do 2 and 3, and x. So that's going to be adding to that what we want there. So x plus 2 and x plus 3. And then on the bottom here we have x and x, Negative 7 and negative 1 is going to give you negative 8. So x minus 7 and x minus 1. Alright, so now there we have that. What you're trying to do now is look to see if you can cancel anything out. Vertically, we can cancel those. Diagonally, we can cancel those. And diagonally, we can cancel those. Which leaves us our final answer of x plus 3 over x minus 1. Not too bad. Just factor and cancel. Okay? Moving on. Okay, so just things to remember. This is a radical equation. Remember that you cannot have anything less than 0 in your square root, and that what you want in your square root is to be a perfect square. So 0 can go in there, but we can't have negative. So if I plug in a 0 there, 2 times square root of 0 minus 5, that's 0 minus 5, negative 5. So on your graph, 0, negative 5. That's going to be your very first point. Then you think of other perfect squares that can go in here. And the next perfect square is 1, so we can put a 1 in here. 2 times square root of 1. That gives us 2 times 1 minus 5. 2 minus 5 is negative 3. So 1, negative 3. And then the next perfect square would be a 4. So we could do 2 times the square root of 4 minus 5. 2 times 2. That's 4 minus 5 is negative 1. So if we plug in a 4, we get out a negative 1. So that goes there. Just basically remember that radical equations always have this kind of curved look to them, and they just abruptly start and then they go off into the positive direction. Okay? Have a good day. I'll send the answers out at the end of this video. Okay? All right. Okay, so here are the answers to the first page, and you can stop and check your answers. There's page 1. Here's page 2. You can press pause. And here's page 3. All right, guys, have a great day.